Alright, we're going to talk all about TCP/IP protocols. Yay! Covered all this stuff here. Alright. It says characteristics. It says it's a suite. It's not just an individual protocol. Everybody hears about TCP/IP, like that's a protocol. Well, no, it's not. It's a whole bunch of them. It's a whole protocol suite. Okay, there's TCP, IP, UDP, ARP, FTP, HTTP. There's tons of them. There's a whole bunch of protocols all built into this. Okay, developed way back when by Al Gore, basically by ARPANET. Okay, come with a plan for it. It's definitely not the quickest out there. Anyone ever use Novell? They have a protocol called IPX SPX. I don't know if anyone's ever heard of IPX SPX. It's a Novell protocol. It's actually much faster, but it's not a standard. So, you know, they don't go with it. All right. Very popular, obviously. Very low cost. Now, what does low cost mean? I mean, cheap like you can go down to 7-Eleven and buy a TCP/IP real quick? Basically means in the functionality and the overhead. There's a lot of stuff. Like when we looked at the OSI model, we talked about the data. We added a bunch of junk to either side of it. We encapsulated it. But still, overall, it's low cost. Okay? Can communicate between dissimilar platforms. We can talk from our cell phones to a web server to a Mac computer to a Unix machine to whatever. It works on everything. It's open in nature. In other words, anybody can develop for it, which a lot of people do. It's routable. Routable is very important. What routable means is like inside this room, we can talk to each other very easily. But if I wanted you to talk to someone in room 206, you'd have to go out this door, down the hall, hang a right, and go into this room. In other words, I'm telling you how to get there. That's what routable means. Okay? Inside this room, no special instructions. We just talk. If I was to tell you to talk anywhere else, that would be something routable. Okay? Could span more than one segment. It's like the internet. We could connect to Google. We could connect to wherever. Okay? Very flexible. It says runs on a combination of networks, operating systems, or media. Runs on pretty much anything. Runs on our cell phones. Runs on everything. Disadvantages: it requires more configuration. Not that much anymore. Way back when they first came out with Super TCP for Windows, worked on Windows for Workgroups 3.1, that was a pile of floppy disk and a couple hundred questions to get it to work. Nowadays it's like, go. You can't even remove it anymore. I think it was Windows 2000, Server Spec 3 or Server Spec 4, one of those two, took away the ability to remove it. Prior to that, you could actually remove the protocol, and I kind of liked it because every now and then it would get screwed up. So what you would do is you install NetBEUI or something, remove TCP/IP, reboot. Put TCP/IP back on, remove the other one, and it would solve a lot of problems. But it was like Service Pack 3 or 4, they finally gave where you couldn't get rid of it anymore. So it's not that many issues with it now anyway, but it does work good. All right, so suite we talked about. So it operates in the transport network layers. Those are near the bottom and not at the bottom. Okay. Has basic services, and it allows other things to work. It allows our email to work. Allows our web server to work, so on and so forth. Okay, and the two main protocols are TCP and IP. One of them's connection-oriented, one of them's connectionless. Do you know which one? IP is connectionless. The way I remember that is an idiot. I for idiot, connectionless. Doesn't have a clue what it's doing. Makes its best guess to get there, you know, but okay. So we're going to talk more about that. Okay, so TCP. Transmission Control Protocol works at the transport layer. Okay, it's connection-oriented, which means we want to make a connection. It's not like me sitting up here and screaming. It's like me and you. Okay, are you listening to me now? Are you listening to me now? You know, we're going to make a connection between each one. You know, it's kind of like a phone call. You know, if you go into Walmart, they scream over the intercom, "Hey, someone left the lights on." They're not specifically talking to any person. That would be IP. That's connectionless. Whereas if they came to every person inside of Walmart and said, "Hey, do you go in what car?" You know, that would be connection-oriented. Okay? So it's connection-oriented, establishes a connection before transmitting. It's kind of like someone calling you on the phone. "Hello? Yeah, I got 3 wrong numbers today in my office. I don't know what's going on." It was like 2 of them are from Canada, and 1 is from who knows where else. But they're like, "Professor Dewey?" I'm like, "Yes, this is Ken Dewey." And they hang up. It's like, weird. I don't know if they're wrong or what, but I never did get to talk to them. But okay. So we establish a connection before we transmit. It has something called sequencing and checksums. Sequencing is we number the packets. It's kind of like, you know, You number the boxes, or you labeling stuff. This we number the packets, that way we know which order they go back in. And when they get there, we can put them all back together in the order they came. Okay. We also do checksums. We talked a little bit about this before. That's error checking. It's to see did it get there correctly. Do we still have all the correct data? Is that my phone? Oh, it sure was. It's off now. All right. Has flow control. It says data does not flow to the node. In other words, we can limit how much data can go across it. We can handle small amounts of data for slow connection, large amounts of data for larger connections. They don't really talk about it in here, but there's something called the sliding window theory. The way that works is I start giving you a small amount of data. Little by little, I keep increasing the amount of data I give you. What I'm talking about is how much before you respond to me. I say I sent you one packet and you reply back, yep, got it. One more packet, yep, this time I send you 2 packets. Then you can say, yep, I got both. So notice now you only have to reply once every 2 packets. If we're getting those 2, then I give you 3. Then you reply once every 3 packets. But it gets to the point where like, whoa, I can't handle that many, and you start giving me errors. Then I slow down again. So I increasingly give you more and more packets until the point where you start giving me errors. And then I slow it down a little bit, and then we come up with a happy medium where the point, it's kind of like, how many bags of groceries can you carry? Can you carry 1, or can you carry 2, or can you carry 3? So same kind of thing. All right. The segment format says it's encapsulated by IP datagrams, which we're going to look at the headers in a minute. But basically, it adds it on there. It's encapsulated inside of it. And we'll see a picture of that shortly. Okay. Here's our TCP segment. So we have some ports, source and destination. Anyone know what the port is for web servers? 80. Port 80. So the source, or actually the destination would be port 80. Now a lot of people don't realize this. When you're going to connect to Google, you go out on port 80. Send a request over on port 80 to Google, and Google answers. Anyone know what port they reply back to me on? A lot of people think it's 80. It's not 80. It's a port greater than 1024. Because really, they're listening on 80. They can't talk on 80. They kind of like have a collision there. So they actually reply back in a different port that my machine's set to answer on. Okay. Sequence numbers. That's that thing, they increment every time we come. It's a 32-bit number. We randomly pick a starting position. Then every time I send you guys a packet, I increase it by 1. And when you get them on the other end, you're expecting you got the starting number, then you accept them in that order. Okay. There is a rhyme or reason to the initial sequence number, and it's actually a TCP/IP flaw. It's been fixed for a while now, but the reason I remember that is the gyms I take care of, when they have their PCI compliance. What PCI compliance is, if you're going to accept credit cards or something like that, you got to get certified every year. Are your ports closed, all this good stuff. Well, a lot of times, there's one gym that kept complaining about there was an initial sequence number guessing attack. The problem was they kept telling me it was on the wrong port, and I had to call them like, oh, sorry, it's not on that port, it's on this other port. I'm like, okay, I understand. But the problem was they kept complaining about their DVAR, their video recording system. If you're going to accept credit cards, and their credit card machine stores nothing locally, but they have a video recording system where people can get in remotely, look at the videos, and there's an issue with the sequence number guessing attack on the video recorder, it always drove them crazy. They're like, oh, that's a major vulnerability. I says, it might be for the video recorder, but it's not being for the credit cards. So worst comes to worst, somebody gets in and watches somebody on the treadmill. It's not like they get in and get into the credit cards. It's 2 totally different systems. So I always have to talk to them every time and explain to them, first of all, their stupid software's wrong. They're telling me the wrong port. But then that it's a different system. So it's a pain in the butt if you ever have to do that stuff. We have acknowledgement. Did the packet receive or not? There's the sliding window thing I was talking about. They have different header links. They have different pointers, urgent, acknowledgement, don't fragment, stuff like that. We're not going to get into in detail on those. There's a checksum. We have some optional stuff. We have some padding to make it a certain length, and we have some data. So a lot of junk up here, and then some data. Okay, that's our TCP header. Okay, here's kind of what it looks like. So our source port could be 80, our destination could be 1958. Whoops. All right, here's some of our pointers. Again, it's not critical you know all these. Okay? And here's our maximum segment size numbers. What's the maximum amount of data you can handle? I think 1500 is the basic standard now. I think it is. Okay? All right, it says 3-segment established connection. We make what's called a three-way handshake. We're going to see a picture of it. It says A issues a message to B, sends a segment in a SYN field. In other words, we're trying to synchronize. We randomly come up with a number. I send it to you. I said, here's a number, and I want to talk to you. Then you receive the message. You send an acknowledgement and the send back. So I send Terry a random number. It says, hey, dude, I want to talk to you. And he says, okay, I want to talk to you too, and here's my number. So he sends me a random number. Then I respond to his random number. They say, I go back and acknowledge him. Then we basically start talking. Then when we're done, we send a fin. In other words, we're finished. Okay? So like, hello, goodbye, that kind of stuff. Here's a picture of it. So we send him a SYN or a synchronize with a random number. He sends him a response. Okay? And then you'll notice my number up there has been incremented by 1 down here. And then his number will get, from that point on, every time I send him a packet, it'll be incremented by 1. It's called the three-way handshake. It's how computers talk with TCP/IP. If we're using SSL, it's actually a 5-way handshake, but we don't get into that here. Okay? Okay with that? All right, UDP, User Datagram Protocol. Okay? It's a unreliable data delivery service. Doesn't that sound bad? It's like, can you imagine someone, yes, I am the most unreliable data delivery service out there, please pick me. Like, what the hell? But it is. No assurance they got there. Okay? No guarantee they'll get there ever. No error checking, no sequencing, or nothing. So why would we ever use something like this? Someone think of an example? How about video streaming? Do we really care if you miss a packet? I mean, when, those places are streaming, when YouTube's streaming videos, can you just imagine if they were, whoa, we lost a packet, back up 30 seconds, missed a packet. That would be terrible. They just want to keep streaming this stuff. So there's a lot of things that do use this. Okay? Netflix. Yeah, Netflix does. Lots of them do. I was actually watching Netflix in the gym this morning, and I usually watch an hour, or I guess a 45-minute show every day on the treadmill or the elliptical machine. But today was weird. I kept hiccuping. So first time it's happened in a very long time on that. It could have been our network, could have been then, but I'm really. Anyone ever use Netflix? Obviously you do. The quality's coming up massively lately. Y'all see the news about them today?
Yeah. Their stocks are.
They're splitting up the company. Now you're gonna have Netflix, which is streaming only, and Quick something. Quickstar is going to be the DVD delivery service. And a lot of people are getting upset about it. But if you think about it, I would want to get rid of the DVD collection or distribution service as well, because that's where the money is. They got to spend postage, everything else, and that's going to die. I'd say within the next 2 or 3 years, there will be no more DVDs. We're getting to the point where everything's going to be delivery, online, or you can have flash drives. There's already in Europe, kind of like we have Redbox here, but you walk up with the flash drive, plug in your flash drive, get your movie in like 10 seconds, and you leave. Automatically deletes itself after a certain length of time. Wouldn't that be awesome? Why do we need DVDs? I mean, we're going to have this stuff here soon. Because just think about it. Even with the DVD, the amount of DVDs they ship, so they're not spending the regular $1 to ship a DVD. They're probably spending, 15 cents. But still, that's 15 cents. How much are they spending when I stream it? Oh, that'll be zero. I mean, they're spending the data cost, but still not nearly as much. So I understand why they did it, but the way they went about it sucked. Did y'all read the article the guy posted? Yes, I realized that my first 3 months in office, kind of made some really bad decisions, but he has good reasoning behind it. He just did it in a sucky way. So.
What about those people that actually collect movies and stuff like that? Well, when they go to all digital, it's like, that's when
you keep the old tube TV.
Well, it's kind of like,
exactly.
How many people collect LPs still? Okay, you can't buy them anymore. It's going to be a point where, you can still buy them, but very, very limited amount. How about video discs? Anyone remember video discs? They were the size of LPs, but they were still, yeah. Can you imagine if you collected those? You know what? Sooner or later they're going to stop selling them, and you're kind of stuck. So if you collect DVDs, it's like VHS. Can you even rent a VHS anymore?
No, but you can buy them.
Yeah, you can actually.
You can still? Because
garage sales.
I take care of a video store out in Hera, Yeah, everyone live out in here?
I've been there.
There's Slick Flick Video. I take care of their stuff. So I get free rentals and all this stuff. But I was there when they started switching over to DVDs. They would get 8 copies on VHS and 2 on DVD. Then now it's like 100% DVD. But they start switching over. But sooner or later it's going to happen. They're not going to be DVDs anymore. We're actually having a discussion downstairs today. How about the telephone? How many of you have a landline telephone? Is there a reason why?
For alarm system.
I have an alarm system.
Well, if you have,
Mine goes through the internet and also cellular. It's actually cheaper.
what kind of launchers do you have?
Well, I use TNT. It goes through cellular or through my network. And man, that's what my message was a second ago. My friend just got to my house and unlocked my house, and I got a message. It notifies me whenever they arm or disarm or anything gets opened or goes off. But is there really a need for phones nowadays? I mean, landline phones. God, does anyone make long distance calls on them anymore? I hope not. I guess if you don't have a cell phone, you could. But I mean, it's going to get to the point where you don't need a home phone anymore. Okay? Same with DVDs. There's not going to be those anymore because things are changing. And you know these wires that got right here? These aren't here for long. Before long, these are all going away. So, wireless is getting to the
I
point.
told my dad that he got argumentative with me. He was like, "No, that'll never change people."
Yeah, it's going that way. It's going to happen. And I'm going to a conference tomorrow, which you all know, no class Thursday.
Right.
Really?
Yes, just so you know. I was actually reading the instructions that I should have done weeks ago. I was reading them today, and they're going to issue me a laptop. It's going to have a wired connection. Why? We're reviewing submissions for grants, so I can understand the security reasons, but come on. WPA2 Enterprise is secure enough nowadays. But I was reading this like, well, issue me an IBM-compatible wired connection laptop. I'm like, okay. Just seems weird. But I don't get to keep it, by the way.
Oh, that's lame.
I know. All right, so UDP is connectionless. It lacks efficient, but it's more efficient. We don't have to worry about checksums and sequence numbers. We're just going to start blasting you with this stuff. And if you can't handle it, well, it's too bad. But the odds are you can handle it. Okay? Great volume of data transferred quickly. Okay? So you can understand why we'd have something like that. Okay? Huh. Yeah, that. Let's go back a couple slides real quick. There's TCP. There's UDP. A little bit less. You got some ports, link, checksum, but still it's not totally. And then some data. I mean, it's really all that sequence number, all the pointers, all that other stuff is now missing. We want to just get it there. We don't really care. It's kind of like the whole rural route. You ever get junk mail at your house where it's not really just to you? It goes to everybody in the neighborhood? It's kind of what this is. Do they really care if you get it or not? No. They just keep throwing crap at you. All right. IP. This is the network layer protocol. How and where data is delivered, including the source destination addresses. Okay. Enables TCP on internet network. Traverse one or more LAN. Blah blah blah. We have a datagram, which I think it's on the next packet I want to talk about. There it is. It's an unreliable connectionless protocol. So why would we use it? It's kind of like, okay, anyone ever mail letters anymore? I do once in a blue moon. But when you mail a letter, what do you do to it?
You put an actual address and a stamp.
Okay, you put an address on it and a stamp. Well, forget the stamp. The stamp's just money. But put an address on there. That's this. This is the address. Just because you address it, does that mean it's going to get there? No. That it's up to the postal service, which is TCP, to make sure it gets there. IP is the address on the envelope. That don't mean a darn thing. It's just the address and where to send it. It's up to the postal service or TCP to get it there. Okay? That's how they work together. Okay? So, no guarantee of delivery. It's like, have you ever got mail for like your neighbor?
Yep.
Yeah. When I ran my business, I would get a lot of packages, and I would say once every other week, or maybe even once a week, I would get a package for someone like 5 doors up. My neighborhood's, my yard's about 300 feet wide, so it's not teeny, but there's a little dip. I would bring them up there, not an issue. But it happened all the time. Finally, one day, I got home, package on my step, called UPS, said I got a package for someone else on my doorstep. Said, sir, would you mind? Nope. I'll hold it until you come and get it. So I made them drive their butts back out to Choctaw, pick up the package, drive it 5 doors down and deliver it. Because I'll tell you what, they never screwed up since then. Because how much more did they have to spend to come and pick up the package and deliver it 5 doors down? But it's like, huh. So basically, they were doing this. They were very unreliable. All right. Is used by higher level protocols for addressing, like our email. Just because we type an email correctly in our Outlook, does that mean it's going to get there? No, it takes something else to make sure it gets there, which would be the SMTP protocol, which we're talking about. Okay. All right. It has a reliability component. It is checking the checksum to make sure the address is correct. Did you put a zip code? That kind of stuff. Okay. Here's the IP header. Got a version, the header length, the total length, the identification, some flags, time to live. Can you imagine if you're addressing a letter to someone for an address that doesn't exist? Say you're going to address it for 84, say it was 8413. I don't know if there was an 8413 in my street, but say there wasn't. And you addressed a letter for 8413 Tree Line Drive and mailed it. Can you imagine that mail dude just driving around for the rest of his life? Darn it, there's 8411, there's 8412, there's 8414. I mean, can you imagine them? I got to deliver this letter. Sooner or later you want to give up. Sooner or later he's going to say, no, there's no address. That's what time to live is. If a packet's identified incorrectly or addressed incorrectly, well, you ever type an address wrong in your browser? Does this sit there for the rest of your life trying to find it? No, you get an error, page can't be found or something, because you want it to give up. That's what this is. The wait time to live, it really depends on the OS and the application. But normally it starts off, I think it's 180. I might be wrong on that. But it starts off at a pretty large number. Then every time it goes through a router, so in other words, it passes your router, it goes to your ISP's router, it goes to their router. Every time it goes through a router, that number gets decremented by 1. And you should be able to get worldwide under 180 routers. I mean, you should be under a dozen routers usually. But it's decremented by 1. When it hits 0, it basically dumps it. It basically says, you know what? We're not going to deliver this anymore. So that's what time to live does. It also works. Anyone ever used traceroute before? Well, I'm going to show you an example of that here in a little bit. Traceroute, that's exactly what it does. It says my time to live at 1. So it heads out, hits the first router, and it quits. It comes up, whoop, sorry, I give up. And that's how traceroute works. Then it sets it at 2. It goes to the second router and comes back and shows. And I'll show you that. Okay. Which protocol are we using? Got a header checksum. Then we have the addressing. There's the address on your envelope. Okay. And then we got some more options and padding and some data. Okay. So good protocol. Pretty stupid though. Okay. Here's what it looks like. Okay. Version 4 is what we're using now, obviously. Time to live is 64 on this one. Maybe there's I can't remember what number it sets it to, but I know it's 180 on something. But I know Linux sets it to 1, Windows sets it to a different one. So and there's our addresses down here. Okay. All right, ICMP, Internet Controlled Messaging Protocol. It's basically ping. Okay. It reports did it get there or not. Okay. Announces the failures to the sender. Handles network congestion. Actually, I'm going to show you that real quick while we're here. I'm going to bring up a command prompt. Actually, you guys are going to need your computers here in a minute. So while we're talking, just turn them all on. If they're not on, they might be on already. I don't know. But we're going to need them in a minute. So turn your machines on. Here's time you actually use something on a computer. Okay, and you might have to turn your monitors on too. Yeah, it's kind of right above the round Dell circle. Okay? I meant to tell you to turn them on earlier, I forgot. It doesn't mean search porn while I'm lecturing. Yeah, I know, I forgot. Sorry. Sorry, man. User counts is user. The password's user, so it should be in. All right, I'm going to show you a couple things here real quick. First thing I'm going to tell you is you can do this when your machine comes up if you want. Actually, let me show you how I got there. You go Windows R or click on Start. You get a search window, whatever. Type in CMD. Stands for Command CMD. Should get a black window like I have. Some of you. Type CMD, hit Enter. Should get a black window. Some of you. Go click on the Start button. Type CMD in that little who's and what's he there. Watch. If I click on, let me get out here. If I click on the Start button, and I type CMD for command, I get that. I want you to type exactly what I'm typing. TRACERT for trace route, and type in a website. www.something. Replace something with a website. Okay. Go TRACERT. Actually, I can make this a little bigger for you guys. CMD. Cat, Mary, David. Lucidia. I already got it at 20. Why isn't it that big? Can y'all see that? So type in TRACERT space www.some website. Pick a website. I'm picking Zombocom. Anyone ever seen Zombocom? I gotta show you Zombocom. Dude, you are gonna love it. Oh, maybe it's Zombo.com. Hold on. There it comes.
Welcome to Zomcom. This is Zomcom. Welcome. This is Zomcom. Welcome to Zomcom. You can do anything at Zomcom. Anything at all. The only limit is yourself. Welcome to Zomcom. Welcome to Zomcom.
Awesome.
This is Zomcom. Welcome to Zomcom. This is Zomcom. Welcome. Yes, this is Zomcom.
See? You liked that, didn't you? That was a good website. It goes on for about 5 minutes. Then 5 says you can buy a t-shirt. Okay. So, I ran traceroute, TRACERT space, and a website name. I don't care which website you go to. What's happening is I'm trying to find my way to get to Zombocom. Okay? In case you want to go home, it's zombo.com. It's amazing. You can do anything at Zombo.com. What's happening is it's using the Internet Control Messaging Protocol to find it. It sends a packet out with a time to live of 1. And you go back up the top so we can see it. Oh, hold on. So it sends a packet out with a time to live of 1. Sends it out and it hits the router. It hits the router down the other end of the hall. Okay? And the time to live, obviously it decrements to 0 and we're done. So it basically sends an error back saying time to live has exceeded. But it reports back to where I got that from. So obviously I got to my first router in 1 millisecond. Then I send another packet to Zombocom, but this time I set the time to live to 2. So it goes through the first router and gets to the second router, which is on the other side of campus. Then, oops, it gets to 0 again, where it sends an error back to me, time to live is exceeded, tells you where. So it keeps incrementing these by 1 each time, and I can follow the line. So we went from down the hall to the other side of campus to OneNet, then we go to the Quest network, then to Dallas, and then to Chicago. I don't know where Liquid Web is. Finally, we make it to Zombocom. Okay, so you should be able to see on yours where you went. Like I'm gonna go to. Let's see. Okay, and the speeds is how long it took to get there. Initially, it was really high because I was playing Zombocom at the same time. I was getting a lot of packets from them. I'm trying to figure out how to get to Tulsa. I'm going to the University of Tulsa real quick. Okay, I hit the router down the hall. I hit the one on the other side of campus. I'm cruising over to OneNet now.
Okay, how do you know?
I just happen to know that number.
Okay.
Yeah, I just know it. That's why. Okay. I don't know where it's going now. I don't know those numbers. Maybe it'll give me a name here in a minute. Maybe it won't.
So let's say you're trying to go to the Rose State account.
Okay.
Would it probably go just as many different places, or would
It-
it just go probably
It
down
should be quicker. Actually, you know what? Did anyone do www.rose.edu? Let me do that one real quick. So I'm going to go to Rose State. Obviously, I'm going to get on the end of the hall first. It'll be 1 millisecond to get there. Then we're going to head over to the other side of campus. Now we're going to go to 1net. Remember, we're just going to row state. Okay, so far we're hitting the same place. Oh, now we're up in Quest. Now we're Dallas. So I hit Dallas twice. I don't have a clue where they are. So what the heck? I thought I went to Row State. Well, our website is no longer hosted at Row State. Our website is now hosted by Element Fusion somewhere. Obviously in Dallas. I would assume that's where it's at. If I go to my.rosa.edu, that's a different story. That's the one that's actually here. They're like the Andromeda test. I guess the test passed, they just never renamed the machine. Okay, so I went down to the other end of the hall. I hit the other side of campus. But rather than going down 1net, I went over to the server. So basically I got there pretty quickly. So that's what traceroute does. Kind of a cool protocol.
What's the 3 columns? I mean, you have 1, 2, 3
It's just
columns.
it sends 3 packets.
Oh, so those are 3 packets.
Yeah, they're all these times. You see up here, twice it was quick, then once it was slow. Yeah, it just sends it 3 times.
Okay.
Yeah. All right. So, go back one. All right. So, reports on delivery or failure. It can be used for network congestion, see if there's errors. It's kind of like, and whenever you use Google Maps, look at traffic. Who's never seen it? It's got to be someone. I'm going to show it to you. I know somebody in here hasn't seen it because I'm going to show it to you. Okay, let's share my location, maybe. Allow. Okay, I'm going to go, let's just go to regular view. And I want to view traffic. Love it. Alright. This is those little things on the side of the highway. Got something pointing at the highway and got a little solar panel on top.
Yeah.
That's the traffic traffic sensors. They're all over the place. So if I'm going to go home now, the 6:15 is about right. Look at this about 5 o'clock. This area right here, it's a killer. Okay, that's where I have to drive through every day. So I love this, and they don't update instantly, but it's like every 5 to 15 minutes or something like that. But it's great. What I do is every now and then I'll just look at this when I'm heading home. I can look at it on my cell phone. I can tell if it's a good idea to take I-40 or not. Yeah.
So red means it's very, very congested.
Yes, and that's right where that construction is. Yeah. And now this is kind of misleading in here because remember they've diverted everybody to the other side of the highway right now, so you don't really know. But yeah, let's go. I drove through Houston a few times lately. Look at that stuff. Isn't that terrible? Yeah, I was driving through here on this loop right in here, right in the center section. Man, it was terrible. But it was kind of cool because I could actually see exactly, because you can make, okay, am I going to exit or not? But I was coming down I-45. I was right in here, and it looked like we were going to be in it forever. But we saw that the moment we got past this turn, it cleared up, so we kept going. So, somewhere on this website, too, I don't remember exactly where, you can actually see the cars. I mean, they show them in circle. Well, they're not now. There's a way to show, maybe it's not on this one. Because you can actually see the flow of traffic. It'll show dots. You know, I don't think it's the actual cars, but I don't know, it's kind of cool. Alright, so it can be used for looking for congestion, can tell you if something fails. There's that TTL expired I was telling you about. Cannot correct errors, just tells us about them. It's like, dude, you got a problem. It's not going to fix it for you, it's just going to tell you about it. Okay? So traceroute, hey, if we were having a problem getting the row state and it stopped at 10.10.254.254, where's the problem? Probably at my router. Or at least it's my router's connection to the next router. It's somewhere in that range. It gives us a good idea of where to look. Okay? Alright, IGMP, Internet Group Messaging Protocol. It says allows one node to send data to a group of other nodes. It's normally used for broadcast type stuff. Okay? It says point to multi-point. That's me right now. One point talking to multiple points. You can send data that way as well. Used for telephone conferencing, video conferencing, routers, never knows that kind of stuff. Okay. Can you imagine Netflix probably uses this quite a bit. Can you imagine if they made a separate connection from their server to every user? Whew, that would suck. It's cached a lot of times. Okay, ARP. Address Resolution Protocol. Let's look at this. Okay, I want you in your computers, keep that window up, that black window. Why don't you type ARP-A. Holy majoli. A bunch. Okay, I'm going to try to make mine a little bigger. Alright. The one I want you to look at is the top one. This stuff. You have 3 of them because you have multiple network cards. You have VMware installed. Type ARP space -A. Everybody do it? ARP space -A. Okay, you should get something similar to this. The very top section, where it lists 10.10.50 and 10.10.0, that kind of stuff, that's your actual network card. The other 2 are your VMware network cards, so ignore those. Okay. Now the first one, what this tells me is how do I connect to something? Okay. When I want to connect to 10.10.254.254, which we saw a second ago, that was our gateway. That's our router. That's this guy right here. Okay? And what it's telling me is that IP address maps to this physical address. Okay? It's kind of like saying Ken Dewey's house. If you looked up Ken Dewey's house right now, it would say 8412 Tree Line Drive, Choctaw, Oklahoma. But if you looked it up back in 1999, it would say 7143B, Tinker, Tree, whatever that stupid road was on Tinker. Can't think of the name. Twining. No, it was before that. Darn it. But
Twining's on Tinker too.
yeah, I know. But Twining, I lived after Twining. I moved to another street. My point is, Ken Dewey's house can change. That IP address can change. That's the router's address today. 10.10.254.254 is it's today. It's been that way for a couple semesters. But when I first installed it, it was something different. So the IP address can change, but the physical address would never change. Okay?
Who changes that?
What?
The IP address. Who changes
I do that.
You change it?
Yeah, I do it. When we reconfigure the whole network or
Okay.
redesign it. When we got our VMware system, we had to redesign it. Because we originally had it with, I don't know, it was 1,000 or so hosts, which we'll see about in Chapter 11. Actually, we'll talk a little bit about it today. But we needed more, so I redesigned it with this numbering scheme so we could handle more computers, which we'll talk more about.
But the physical part always stays.
Right. The physical doesn't change. This is encoded by the manufacturer. You can't change it. You don't have to do this. I'm just going to show you where to do it if you wanted to. If I went into the control panel here, and I went into networking, and I went into adapter settings, and I went into my local area connection properties, then if I went into TCP/IP, is that where it's at? No, it's not there. Hold on. It's this one. It's configure the network. No, yes, I want to continue. Just do it. Advanced. Darn it, that's not it. Hold on. Oh, I did it just recently. Where the heck's it at? Oh, I did it like 85 times. You'd think I'd remember. It's not there. It's not detailed. Hold on. Okay, it'll say some weird name. Like, not manufacturer, be local something. No, I don't see it. Hardware ID. That's not it. Darn it, I can't find it. Well, it was in here somewhere. You could change it. I'd just be darned if I can see it right now. I don't remember. I thought it was in here. Well, maybe not. Okay, driver details. Already. Let me check one more thing. It's not there. Can't be here. Well, I don't remember where it's at, darn it. There's a way to change it. I'll be darned if I can remember where to change it. I had to look it up last time, but basically you can change that number. Okay?
It doesn't actually change it, it just broadcasts a different number?
It's stored in firmware on your network card. This is. But you can actually go in and update it. When manufacturers make your network card, they assign a number to it, but can you imagine if they didn't have a way to adjust it? And that would kind of suck. If there was ever a duplicate, you kind of, oh, throw that one away. Yeah, they have the ability to update. Okay, I can't remember where it's at. I did it a whole bunch the other day, actually in this room even. So that's the physical address that's embedded on the card. And this is the IP address. Now these numbers here are our DNS servers. We're going to talk about them here in a little bit. 10.3 and 10.4 are DNS servers. Those are kind of like the phone books. When I type in zombo.com, my computer's an idiot, says I don't have a clue. So I send a request to my DNS server, says, hey dude, where's zombo.com at? And they came back and told me. But I had to figure out where they were first, so that's why I had to resolve them. So I used ARP-A to resolve them. Now, watch and see if this changes at all. So I got 1, 2, 3, 4, 5, 6, 7, 8 numbers in there. 1, 2, 3, 4. Darn it. Someone tell me what's this address on one of your machines? Someone tell me.
10, 10, 50, 14.
Okay, should work. What can I see? Oh, I bet we got firewalls on these machines. Great. There we go, we got one. I bet we have firewalls on. But this list right here, it's higher now. I got two extra ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got an additional one. Whenever I look up another address, I add it to my list. Now I remember it for 2 to 10 minutes. Okay, 2 minutes is something that I used once. First time you ask me something, I look up an address, I'm going to remember it for 2 minutes. I'm going to get rid of it. Why keep it for longer than that? Kind of like, if y'all were going to call me, you'd look at my number and then you're not going to call me again, so you'd forget it. But if it's something you call all the time, you're going to remember it for 10 minutes. So 2 to 10, depending on the frequency of use. So some of these things I use more often. If I don't serve the internet for a while, don't have updates going or anything, these top 2 will drop off. The gate will always stay there, though, because that's something I talk to all the time. Okay? All right, again, these are your VMware adapters down here. And these physical addresses, you can actually find out what type of network card it is just by looking at them. Okay? You can actually look up these first couple octets or hex values. It'll tell you the brand and model of your network card. So, kind of handy. All right, let's move on. All right, so the ARP address obtains the host a physical address, creates a database, and maps the physical address to your IP address. So the IP address to the MAC address. Okay. We have the ARP table, which is in cache. It's a database on computer's hard drive. Contains the recognized MAC to IP address mappings. It doesn't stay there very long. They don't tell you that in here, but it increases efficiency. Can you imagine if every time I needed a DNS entry, I'd say, okay, where's the darn DNS server? Because out there when I'm surfing the web and surfing I'm using DNS quite a bit, so I want to remember where the DNS server is. So I look it up and I'm going to remember it for 10 minutes. Now if I stop using the internet for a while, then I'm going to forget it, but still rather than ask it every time where the DNS server is, I can remember it for a while. So it increases my efficiency. And we never see those, I don't see them too much anymore, but I used to have a lot of advertisements out there how, this dial-up service was so much faster than this dial-up service, even though they were both dial-up services. How was one so much faster? You never see those commercials?
Yeah.
Okay. Net zero and
Yeah, net zero compared to someone else. One was like 3 times faster than net zero. Well, what it did is it cached your DNS entries. We're going to talk about DNS here in a minute, but what DNS is the phone book. When I type in www.zombo.com, I send a request out that says, yo, dude, where is Zombocom? And my server went and found it and told me where it was. But I forget about it. After I've been, right now my machine has no clue where Zombo. I can actually go IP, oops, hold on, I'm not in the right slide, I'm not in the right thing. I could go ipconfig -display DNS, okay? And this is every single place my machine knows about. It knows about Google right now, knows about Google a lot, knows about the Active Directory controller, knows about Quest. It still remembers Zombocom. So it's remembered for a few more minutes. Okay? But after a while, it's going to forget it. Okay? Those services, what they would do, well, they would set it never to expire or expire for an exceedingly long period of time. Instead of 30 minutes, maybe 30 days. So the next time you want to go to Zombocom, it's like, oh, I know where that's at. It's kind of like, you know your wife's or your parents' or your brother's or your sister's phone number. You can just dial it. You don't even have to look it up. But if you had to look it up every time, it'll be slower. That's how NetZero or whatever was quicker than the other one, because one of them just stored it longer. That's all it was. First time you went to that website, it took just as long. But after it goes there one time, it stores it. Just the address. It's a good thing and a bad thing. It's a good thing because it speeds it up. But it's a bad thing. What if it changes locations? What if Zombocom moves to another server and my machine knows the Zombocom is at whatever the address that just was? I'm not even going to go look for it. I'm going to say, I know where Zombocom is, but the darn phone number's been changed. So I'm going to be going to some other weird, bizarre website that's not Zombocom. So there's good and bad things about it. Okay? All right. So we have our table, increases efficiency, does all that stuff. Okay? There's two entry types, dynamic and static. Dynamic, the ones we were just talking about, automatically get added. Okay? Static is ones that are there by default. Okay? You can manually add those. Static entries are not always a good idea. Imagine if I told you, okay, you all know where I live now. What if I said, to get to my house, you take I-40 East to Charter Road? Not an issue. But what if there's an accident? What if the road gets blown away? And the only way I know how to get there is I-40 East. Remember when I-40 that bridge got blown away over the Arkansas River?
Yeah.
Can you imagine if the only way you knew to go to Tennessee was I-40 East? You'd be sitting there for 6 months. You'd be like, nope, the only way to go is I-40 East. But, so static entries don't give the ability to change. I mean, it's kind of like saying, to get to Zombocom, you go here. What happens if Zombocom moves? You're kind of screwed. So you have to manage that stuff. Okay. The ARP utilities, what I showed you, you type ARP. Okay. Works in both. Okay. Provides the information. Okay. Also provides a way to manipulate. You can add stuff. You can delete stuff. If you go into the ARP table here, if I type ARP dash question mark, it tells me all the different things I can do to it. I can display the ARP entries. I can, geez, his name is A, okay. I can display them for certain, for post mode. I can specify an IP address. I can delete an entry. I can do wildcard. I can specify for a certain adapter type. So a lot of different stuff I can do. Okay. Kind of a good protocol, but a very bad one as well. Anyone ever heard of man-in-the-middle attacks? Okay. ARP is, there's a word for it I can never remember. I haven't remembered it in like 6 months now. The ARP protocol trusts. If I was to come in today and said, my name is Ronald Reagan. Okay? Obviously it's not, but what if I did? What if I told you that and you believed me? Totally believe me. For now you're like, oh my God, Ronald Reagan's my teacher. That's what ARP is. I can go to ARP. Right now we saw the physical address of the router down the hall. What if Terry over there was to say, oh, sorry dude, I'm the router. ARP believes it. If Terry was to tell ARP that he's the router, guess what would happen from now on? Any traffic would be sent through Terry. And it's very easy. We're going to play with a program later on in the class called Kane. 2 clicks of the mouse, you can do it. Imagine being in IHOP and telling every single laptop in IHOP, oh, by the way, I'm the gateway. And every single packet in IHOP is going through your computer. You can bring a Wireshark, you can capture the traffic, see where they're going. It's super easy to do. So the protocol has no security built in. It basically just does it. So think about that. It's exactly how it works. So I'll show you that later on. We don't have time today. Okay. Here's what it looks like. Kind of what you guys saw. It's kind of, mine was prettier. All right. RARP, reverse address. Now we're going to do the opposite. We're going to go from the address to the IP address. MAC address to IP address, okay? Now I get, instead of the MAC address, now I get the IP address, okay? So it basically works in reverse. Oh, hence the name. All right. IP version 4, that's what we're using today. Are we going to use it forever? What do you think? Probably not, but I don't know. I've seen weird things. It's kind of like the stupid decimal system. We've been using decimal system or the, miles per hour forever. Will it ever change? No, even though we should, because we're idiots. Okay. Okay. IP addressing says recognizes two addresses, our logical and our physical address. Our logical is the IP address. It's that number that can change. You might have a certain address today. You could have it different in 5 minutes from now. You probably won't, but you could. The physical address is that MAC address, the firmware assigned to your network card. Okay? And we can change that, but it's not normally done. Okay? The handle is the IP protocol. It handles addressing. Again, it's just like writing a letter on a stamp. Writing an address on the letter. There you go. Writing a letter on a stamp. Okay. Address on the letter. That's what this is. Okay. Has certain parameters. It's a 32-bit number. So how many bits is it? 32. Very good. It's divided into 4 separate octets. So here's 4 pieces. 144, 92, 43, 178. 4 octets. Called octets because each piece is broken up to 8 pieces. 8 bits makes up each of those addresses. Okay, so divided into 4 octets, separated by periods. That's exactly what it looks like. Okay? We'll talk a little bit about that. We'll do a whole bunch more in like chapter 10 or 11 or 12, one of those. Okay, we've got a couple different types. We have A, B, and C. Not used anymore, but they're still out there. A addresses are for large networks. Okay? So there's only 126 of them, but each network has 16 million computers. So what's a big network, you think? Give me an example of a big network. What do you think?
Military.
Actually, military is a B. Military is relatively small. I would always thought military was not small. HP was a big network. Hertz is another very big network. AT&T is a big network. Cox is a big network. Okay. So we're thinking there's a limited number of those networks, but each network can have 16 million computers. Okay. Class B, that's the military. There's more of those. Okay. There's 16 million approximately. And each one of them can have 65,000 computers on it. So can Tinker Air Force Base is 65,000 computers enough? I'd say yes. I'm not saying the whole military has to fit in 65,000. I'm just saying each network can only have 65,000. So Tinker can only have 65,000. Okay? Or Class C. Those are normally like for an ISP. There's more than 2 million of them. They can each have 254 addresses. The way you tell the network apart is by the first digit, the first number. So if I was to tell you this number right here, 144, which type of network is it? A, B, or C?
B.
It'll be a B. Okay? So a medium-sized network. Okay? I ran a network out of my house. Which type of network should I have?
C.
My first digit was a 66. What the hell? Why would my address be a 66? It kind of blows this whole scheme out of the water. Well, this was the original idea. Then they realized pretty quickly after that this idea sucks. So what they did is now we use something called classless interdomain routing, which we'll cover more later. But Cox is my ISP. Cox was a large network. Cox was a Class A. Then what they did is they took their scheme of 16 million addresses, give me a little piece of it. Okay, this corner over here, the teeny tiny corner, belongs to Ken Dewey. It's kind of what they do now. We have Cox at our house. Now we even get 1 address or 2 or however many you're purchasing. So you're probably a 66 address if you look at your house. Okay? In this room, actually, one that was showing you is a 164 address. 164 is a B. It's about right size. But it doesn't have to be that way anymore. They ran out. There's actually none of these left. Every single IP address has been dolled out. They're all gone. Does that mean you can't get one? No, it means Cox has theirs. They've already got their chunk. It means they can still give you one of theirs. But you cannot go to ICANN and say, hey, can I have an IP address? And they'll be like, oh, dude, we ran out like a year ago. So, it's true, we're out. Okay? So, it's determined by the first octet of the address, A, B, or C. Okay? Wow, we're almost out of time? Damn it. I thought we were going to get more than this done. All right. So, we also have D and E. Okay? D is multicasting normally, and E is experimental, not used very much. Okay? Experimental use. Okay. 8 bits have 256 combinations. Okay? I actually saw, hold on, I'm going to show you this. We're not going to finish anyway, so I'm going to show you this. I got to show you this. There's a new thing today.
So why is Google changing every time you go to it?
Come on, click.
Because they can.
Well, I'm
After
trying to click the
all
button. It sure ain't clicking. There it goes. See if it's on here. I think it was on this one. Darn, it wasn't on this one. Oh, it's on my Facebook account. Gotta see it.
That's on your Facebook account?
Let's see.
It's because Google probably owns Facebook.
Come on. You do it.
Oh, what?
It's on here today. Can't be that far away. Well, how far back am I now? Oh, there it is. I love it. Yes. Did we talk a little bit about binary in here? I did talk a little bit in here.
Yes.
Binaries are ones and zeros. That's it. So it says on a scale of 1 to 1, 0, which is 2, by the way, how likely is this question is in binary? 4? What's a 4? See? Got it? Okay. Come on. You gotta love stuff like that. All right. So, IP addresses, if you have 8 bits, okay, we'll go more into this, but then we get through the chapter. You have 8 bits of 1 or 0. 2 to the 8 is 256. That's the maximum number of addresses you can have. Okay, if you went in binary, change every, from 1 to 0, all 8 bits, the maximum combination you can have is those. Okay. Network use is 1 through 254. What the heck does that mean? Well, 0 is actually what's called the network ID. Okay, it's kind of like rule route 5 or tree line drive. Okay, I live on tree line drive, but can I send mail to tree line drive? Well, not really. Tree line is the street name. If I want to send something to tree line drive, I need to say the number at tree line drive. So the first digit is the network ID. It's kind of like the street name. The last digit is like the broadcast. That's like your rural road 5 to send it to everybody at tree line drive. Okay? So when you're out of this number, you really can't use all of them. The first one and the last one are gone. First one's like the street name, or it's called the network ID. The last one's the broadcast. So if you send information to the last address, everybody gets it. Okay? All right. It says any devices, the first octet is the network ID. In other words, that first number, that 144 or whatever we looked at there. The last 3 octets, or bits 8 through 31. Now I said 8 bits. How come this says 0 to 7?
So you have a 0.
Right, they're counting 0. This is 0, 1, 2, 3, there's 8 of them there. Okay. So 0 through 7 is the network ID, the rest is the host. Class B, the first 2 octets, the first 2 numbers are the network ID. The last 2 are the host. Class C, the first 3 are the network ID, and the last 1 is the host. Okay. We'll see more about that. Okay. Here's a graphical picture of it, yes. All right. All right. There's also something called the loopback address. Loopback address is me. It's for testing purposes. You ever want to make sure your network card's working, ping that address. If I went in here on my computer and I typed ping, I got too much of this. Wow, it's getting there in less than 1 millisecond. Because basically what it is send a request down my TCP/IP stack to the bottom and right back up. That's a very good testing utility. Okay. Yeah, it just works good. It's a loopback test. This is attempted to connect to its own machine. It's very good for troubleshooting. If it doesn't work, then you got a problem. If your network cable's unplugged, your network card's disabled or something, that won't work. Okay. On Windows, use ipconfig. What ipconfig does for you is, I will show you. Yeah, IPconfig tells me information about my network card. Okay? It tells me, well, if I can slide it over, tells me my DNS suffix is rows.lab, here's my IPv6 address, my IPv4 address, my subnet mask, and my gateway. I can also specify things like all. I can get a lot more information. Okay, now I got my Intel network card type, I got my lease obtained for my DHCP server, I got who the DHCP server is, IPv6, everything. I got all my DNS servers down here. Okay, so get a lot of information. So IPconfig/all will give you all the information. Okay, there's a lot of other commands you can use as well, like display DNS, which I did a little bit ago, where I saw zombocom in there. In Unix and Linux, you do ifconfig. It's for interface config. Okay, so it's IPconfig in Windows, ifconfig in Linux. Okay, we got 5 minutes or 10 minutes. That clock's off too. All right. There's IPconfig all. It tells us a bunch of information. Tells us routing is enabled. Tells us our MAC address. If DHCP is enabled, which we're going to look at in a minute. If auto configuration is enabled. Just lots of information. Tells you when my lease expires. And again, I edited the slides to include that now. So. In Linux, here it goes. ifconfig instead of IPconfig. Tells you pretty much the same information. And, it tells you a little bit about packets and a little bit about other things. All right. It says binary and dotted decimal. It says decimal numbers between 0 and 255 represent each octet. Okay, so those 4 numbers can be converted to binary. Okay? Separated by a period, and each one has a binary equivalent, blah, blah, blah. We can convert each, we can remove the decimal points. Okay, and we're going to actually look into doing that. Just not yet. Subnetting. Okay, it says identifies every device on your network. It's kind of like a zip code. If I told you 8412 Treeline Drive, and that's all I said, could you find my house? Well, you guys seen a picture of it, you probably could. But if you hadn't seen a picture of my house, you didn't know what city I was from, would you ever be able to find it? Heck no, you wouldn't have a clue. The subnet mask is like the zip code. It tells you where my house is at. It tells you what city you're in. Okay, that's what the subnet mask does. Okay, identifies your subnet, combines the device's IP address, and we'll do a whole bunch with this because we're going to learn subnetting in this. I think it's chapter 11. Does anyone have their book? Is chapter 11 more about IP addressing? I can't remember. It was 11. I'll cover it next, actually. Whatever chapter this is. What's this one? Ah, so it's 10. We're going to do 10 next time. Okay.
We're going to go to 10 after 4?
Yes.
Okay.
All right. So, combines it. It basically tells you which part is the network, which part is the host. And basically we have 4 octets we talked about. We can assign them automatically or manually, which we're going to look into as well. Okay. Here's the default subnet mask. So for a Class A network, you normally have this, 255.0.0.0. The 255 is your network ID. All the rest are your hosts. With Class B, the first 2 are your network ID. The last 2 are your host. Class C, the first 3 are your network ID. And the last one is your host. Okay. So the 255 is your network ID. The 0 is your host. Okay. Subnetting, we divide it up. Okay. We divide it up into smaller pieces. Okay. But obviously that way is not very efficient. Because we either get 16 million, 65,000, or 256. What if I need 500 or 1,000? That doesn't give me the choice. I either get 16 million, 65,000, or 256. So if I needed 500, I would have to get 65,000. Kind of a waste. Okay. So it divides it up. It helps control traffic. Because one subnet doesn't talk to another subnet. So if I was to go in this room and make this wall one subnet, this wall one subnet, this wall one subnet, that wall one subnet, you could talk to each other, and that was it. Unless we did routing as well. But it basically divides it up. So if we were broken up into 4 subnets in this room, these guys could talk back and forth all day long, and it wouldn't interrupt anyone else in the room at all. So kind of cool. Okay. The mask varies, which we're going to learn about. It says non-subnetted network use defaults. Basically, if you don't specify, it's going to give it to you. It's going to say, it's going to look at what you're putting in for the IP address. It's going to look at the first digit. Like when I put in 10, it automatically gives me the 255.0.0.0. I have to change it to 255.255.0.0. Okay. All right. Assigning them. It says the government gives them out. These guys do. IANA, ICANA, they all give them out. They're all gone now. Okay. Then the companies and individuals get them from their ISPs. You get yours from Cox. We get it from Rose State. We get it from whoever. Okay. Every network node has to have a different IP address. Or else they don't work. Okay. I think we are. Yeah, let's stop. Actually, we'll do this one. Okay. Assigning them, I can do them statically. I can go to each machine and give it an IP address. When I worked at Tinker, that's what I did. Went through every computer in AWACS, gave them all a manual address. I said, this is stupid. Why aren't we doing it automatically? Oh, no, I can't do that. Then about a year later, we did it again. Went through and gave them all a different IP address. My dude, this is stupid. Why don't I do it automatically? Oh, I can't do that. Well, they are finally doing it now, which you can do it automatically. They were just stupid. But, so static ones are assigned manually. I have to go to each computer and change it. It's a pain in the butt. But servers are done that way. Like all of our servers down the hall are manually configured. I don't want them to change. I want them to keep the same address forever. But there's only a handful of them. Do you think I went to every computer in this room and manually assigned them one? No. We used to do that, but we don't now. Okay. Human error can cause duplicates. You can forget what you're at. You can mistype a number. A lot of problems. Or we can do it automatically via BootP or DHCP. We use DHCP now. BootP is kind of gone. But DHCP, very handy. We're going to go into that, I think, next time. Yes, because we're basically out of time. All right, we're going to pick up on 38 next time. Okay? Actually, that'll be Tuesday, by the way. Are we okay with that? Tuesday, we're going to pick up on 38.